Hi everyone. So today we are going to start with polymers. We have already completed organic chemistry and we have divided it into different parts. We have covered all the functional groups, their reactions, and their structures separately in all the videos, also their structural isomerism part. Okay, and today we will start with polymers. So, polymers are somewhat connected to organic chemistry because polymers that we are going to learn are made from alkenes. So, for that, you should know the structure of alkenes. Okay, so yeah, now what is a polymer? Now, poly meaning many, poly means many. So, we would say that there are many repeat units. We have many repeat units connected together, connected together to give a long chain. Okay, to give a long chain. That is known as polymer. That is known as polymer. Now we have two types of polymers. Okay, we have natural polymers and we have synthetic polymer. We have synthetic polymer. You would be aware of natural polymers. So, for example, proteins. Proteins are having complex structures. Okay, and proteins are made up of amino acids. Proteins are made of amino acids. So, we can say that many amino acids combine to form long chain compound. Okay, that is known as a protein. The examples of protein that we know or that we have in our body is keratin, that is present in our hair. Then we have collagen, which is present in our skin. Okay, these are some common examples. Now, when we have synthetic polymer, so the common example of synthetic polymer is plastic. Okay, synthetic polymers are plastic. When we talk about natural polymers, it is not only protein, but we have carbohydrates, which are also called as polymers. We have wood, which is also called as natural polymer. Okay. When it comes to synthetic polymers, we have plastics basically. Okay. And in plastics, we have polyethylene, polyvinyl chloride, and all that, which are different examples of plastic. Okay, so the concept remains the same that many monomers, we would say, okay, many repeating units would just keep on connecting with each other, and a long chain compound is being formed, which is known as a polymer. Now, the polymer is made from monomer. Okay, so we have a monomer. Now, what is a monomer? So, a monomer is small molecules used to make polymer. Okay, we can say they are the smallest small repeating units. They are known as monomers. And what is a polymer then? It is a large molecule made by repeating unit of monomer. It is a large molecule which is made up of repeating unit of monomer. Okay, the process of making of polymer is known as polymerization. The process of making of a polymer is known as polymerization. So it is a process in which thousands of small molecules join to make a large molecule. Okay, that is polymerization. Now we have two types of polymers. Okay, we have two types of polymers again. One classification was based on whether it is natural or synthetic. Okay, the another classification that we have is by the method which is made. So we have addition polymerization, and second is condensation polymerization. Okay, we have addition polymerization and condensation polymerization. Now, how these two are different, what is required to make these two? So, for addition polymerization, we require a monomer with carbon carbon double bond. Okay, and only one monomer required. Okay, so we have a monomer, we should have a monomer where it should have carbon carbon double bond. Okay, so we can say alkenes are used in making addition polymerization. In case of condensation polymerization, we require two monomers with two different functional groups. In condensation polymerization, we require two monomers, okay, and both the monomer will have a different functional group with them. Okay, so this is the difference of a polymer addition polymerization and condensation polymerization. In condensation polymerization, we can say only one polymer is made, one product we can say is made. In condensation, we can say polymer plus water. Two products are made. Okay, so this is the difference of addition and condensation polymerization. So let's learn addition polymerization. Now, to make addition polymer, okay, we have to arrange the alkene in such a way so that it has an arrangement of a monomer. Okay, so I will just take simple example of ethene, and I will make a straight chain ethene, which is CH2 double bond CH2. This is my structure of ethene. Now I have to arrange this in such a way, okay, so that it should look like a monomer. Now I have two carbon atoms. Here I have two hydrogens. So I am supposed to draw it in 90 degrees to the carbon. I have to leave this space empty so that more of the ethene molecules can join here. Okay, I have to leave that space empty. Okay, and I have to arrange all the atoms which are attached to carbon in 90 degrees in such a way that the side of carbon atoms is free, available for other alkene atoms to join. Okay, so here this is my monomer ready. So I will just draw the monomer inside a bracket. So this is my monomer. Now, N here is there are so many molecules, okay, N number of, we would say, monomers are added together. For example, we would say 5,000 or 8,000, 10,000, 12,000, like that. Okay. Now, how will the polymer look like? So, the only difference here is the double bond will be changed here to a single bond. So, carbon, single bond, carbon. We have to write the hydrogens as it is here. Okay. And this becomes my 1 unit of polymer. 1 unit of polymer. The monomer which I had used was ethene, so the name here becomes poly because it's a polymer, and the monomer which I had used was ethene, so the name becomes polyethene. And what I have made here is 1 unit of polymer. Okay, the whole polymer looks like this only, and it is just one part which I have taken. If I have to draw, for example, two more units or 3 units, I will just repeat the structure in a continue format. Okay, so if I have to say, for example, draw 2 units, so in 1 unit I have two carbon atoms, so in 2 unit I will have to just repeat the structure. So it is 1 unit, and it will get connected to, this is my second unit. This is my second unit here. I'll just write hydrogen, 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 hydrogen everywhere. Okay. Yeah, I just forgot one thing. You have to draw this bond extension. This shows that on right and left on both the sides, there are the same alkene molecules which are attached. Same here also, we have this bond extensions. This is my two repeat units of polymer. So this is my monomer. I have made 1 unit of polymer, and this is two repeat units of polymer. This is how my whole polymer chain is going to look. Okay. Now let's take another example and convert it into a monomer and then convert into a polymer. Okay. So let's take example of propene. We'll take an example of propene. So first I will draw straight chain propene, which is CH3 CH double bond CH2. This is my propene. Now how to convert this into a monomer? I have to understand one thing, that my carbon carbon double bond is important. Okay, this is the important thing. So I will first write the carbon carbon double bond here. I will write the carbon carbon double bond here, which is C double bond C. Now I have to understand, as I told you, that we have to write the hydrogens according like 90 degrees. Okay, so to my first carbon, if you see here, I have two hydrogens. So one hydrogen above, one hydrogen below. To my second carbon, I have one hydrogen and a methyl group attached. Now it is up to me wherever I have to put the methyl group, above or below. Okay, there is no specific arrangement for that. So here, as I mentioned earlier, this area, the left and right side, should be free. Okay, so this now becomes my, this becomes my monomer. Okay, this becomes my monomer. Now, how am I supposed to write the polymer from this? So, I will copy down the whole structure as it is. Just the double bond will be single bond now. So, this is carbon, single bond carbon. All the groups I have to copy down same as it is. Hydrogen, 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 CH3. Okay. And I have to show bond extension on both the sides. This becomes my polypropene. This becomes the structure of polypropene. Okay, so whenever you need to make a monomer, first write the straight chain compound with pencil, arrange all the atoms according to a monomer, and then copy the same structure to make polymer. Just convert the double bond into single bond. This will give you your polymer. Okay, we will do one more example here. That is, let's take example of butene. Okay, so butene is CH3, CH, double bond, CH, single bond, CH2. Sorry, CH3. Okay, now here again, as I told you, I have to arrange this. I have to focus on carbon carbon double bonds. So I will have carbon double bond carbon. To my this carbon, I have one hydrogen and a methyl group attached. So a hydrogen and a methyl group attached. To my this carbon also, one hydrogen is attached and a methyl group is attached. So let's change the position. CH3 I will write above and hydrogen will be below. This makes my monomer. This makes my monomer. Now have to draw its polymer So I will copy the same structure again. Just put a carbon carbon single bond. Okay, copy the same structure HCH3 CH3H, and then draw bond extensions on both sides. This becomes one repeat unit. Okay, so this becomes one repeat unit. Now, in exam, mostly they either ask you to draw one repeat unit or three repeat units. So, when I want to draw three repeat units, I just have to copy the polymer three times. Okay, and just keep on connecting it. So, this whole is my one unit. Okay, so I will show three repeat units. So, this is my one unit. Then I'll connect it with two more carbons. This becomes my second unit. Connect it with two more carbons. Okay, bond extension on both sides. So HCH3 CH3H. Same I will copy on the second repeat unit. Same I will copy on the next carbon atoms. This becomes my three repeat unit structure. Three repeat unit. Three repeat unit of my polymer. This is how you have to draw. Polymers are very easy. It is just to arrange the straight chain compound into monomer and then copy the same structure to make polymer. Just to remember that we have to convert this double bond into a single bond. Rest the whole structure we have to copy as it is. Okay. Now this is all about when we have to convert a monomer into polymer. Whatever we learned till now was monomer to polymer. Now in exam they also ask you questions which are polymer will be given and you are supposed to draw the monomer. Okay. So polymer will be given to you and you have to find out which is your monomer. So let's draw a polymer here. Okay. I will be drawing a polymer. Now in this polymer, from this polymer you have to draw the monomer. Now here you will have to identify any two carbon atoms, any two carbon. Okay, you consider any two carbon atoms whichever you want. Say for example, I consider this two carbon atoms, or some of you might consider this two. Okay, anyone it can be. There is no problem if the chlorine, if you see here, it is on right hand side or it is on left hand side, that is not going to cause any problem here. You just have to consider any two carbon atoms. I will draw this structure as it is below. This structure which I have drawn a bracket, square bracket, I will just copy it down as it is. So I have here hydrogen, Cl and H. Now to make a monomer, we require a carbon-carbon double bond. Just put a double bond here and this makes your monomer ready. If I want to make for this structure, I have to copy it down same as it is. So carbon-carbon bonds, hydrogen and Cl. Again, to make a monomer, I just have to put a carbon-carbon double bond here and hence my monomer is ready. Both these monomers are correct. So in exam, they will be giving you polymer and you have to identify, you have to consider any two carbon atoms. Okay, draw the same structure below as it is copied down and just draw carbon-carbon double bond below. Hence, this will give you your monomer. Let's take one more example here. I will draw one more polymer. So again here, if I want to make a monomer, say for example I consider this, or I can consider this also. Okay, any one you can consider. I will copy down the same structure here and just put a double bond. This is my monomer. Or if I want to make this one, so it is this is also my monomer. Just a double bond here. So making monomer from the given polymer or making a polymer from the given monomer is very very easy. Students usually skip this question or say that they don't understand how to do it, but if you pay attention, you will understand how to solve this. Okay. Now in exam also, after drawing the monomer, they might ask you what is the name of the monomer, which monomer you were using. So let's write the name of this compound. First of all, we will number it. Okay, this is my first carbon, second carbon, and I have two more carbon here. Okay, so in total I have four carbon atoms. Total four carbon atoms I have. Okay, C2H5, C2 means two carbon, and these two. Now four carbon atoms I have, and you can see that I have a double bond at my first carbon atom. So four carbon atoms, meaning the prefix will be but. Then I have double bond at first carbon atom, and I can clearly see that it's an alkene, so I will use E and E. So but 1-ene. So the monomer which I have used to make the polymer was but 1-ene. Okay, this is how they can ask you questions in exam. For addition polymerization, they might ask you to draw the polymer, 3 repeat units or 1 repeat unit, or a polymer will be given to you. You have to figure out the monomer and write the name of the monomer which is being used here. Okay, yeah, so this is all about addition polymerization. Next we continue with condensation polymerization. So for condensation polymerization, as we have learned earlier, that we require two different monomers with two different functional groups. So we have the two combinations here. First is carboxylic acid, and second I have is amine. You can see that I have drawn a displayed formula for both the structures. Let me shade one of them. Now, again, here we are going to remove hydrogen from amine. Okay, first of all, let's write the name. This is di, because we have two carboxylic acid functional groups here. You can see dicarboxylic acid. And NH2, this is NH2, what you can see, NH2. Okay, I have drawn NH2 on both the sides, and hence this is also diamine. Amine is the name of NH2 functional group. Okay, so the box which you can see here is alkyl chain, or you can say carbon chain. That carbon chain can be anything. It can be made up of 10 carbon atoms, 15 carbon atoms, 100 carbon atoms, or anything we can say. Okay, but here we are not concerned about the box. So instead of writing the carbon chain again and again while drawing the structure, we have converted it into a box. We will be representing the carbon chain as a small box here. Okay, one is unshaded and the another one is shaded. This is how they ask you in the exam, and this helps you to identify or differentiate between both the functional groups, both the monomers, you can say. So here you are supposed to remove hydrogen from both the ends of amine functional group. So I will remove hydrogen, and again I have to remove OH from carboxylic acid. Okay, I will remove these groups. Now OH and H is going to combine and give you water molecule. Here I have removed two OH and two hydrogens. Hence I am going to get two water molecules, that is 2H2O. Now I am supposed to copy the same structure which is remaining here, which is this carboxylic acid box and another C double bond O and NH, this box and NH. I'm just going to connect these two structures, copy it down as it is. Okay. So here I will just draw them. Then alternatively you have to write both of them. So I have drawn my carboxylic acid. Now I will draw amine and I will just draw a bond so that I can connect with it. So it is NH. Again I will draw carboxylic acid, draw a bond to connect. Again amine I will draw. Okay, and I have to show bond extensions here and here. So this is a chain, you would say. This is how the whole polymer chain looks like. Okay, now this is the linkage, you can say. So C double bond NH is known as amide linkage. This linkage you also see similar linkage in proteins also. In proteins you would call it as peptide linkage. Here also you can call it peptide or amide linkage. So this is known as polyamide. Example of a polyamide which is having amide linkage in it is nylon. Okay, so the two products you have is one is your polymer and the another one is your water. I will just write it here, H2, 2H2. Okay, so you have to alternately copy one after the other monomers and hence it will give you a big chain. Okay, this is how you draw condensation polymer. This was your first polymer that is having a polyamide linkage. Now we will move towards the second one. So for the second one, carboxylic acid remains the same. So we have dicarboxylic acid. Yes. So we have dicarboxylic acid. And if you can understand here, OH is attached on both the sides, and yes, you are correct. We are using alcohols here. Again, we have two OH functional groups here, so we will use the word di, and instead of writing that whole word alcohol, we will just use OL, diol, name ending of alcohols. So this is diol, and we have dicarboxylic acid. And yes, here we are going to make esters. Okay, so if you understand, carboxylic acid and alcohols are actually reacting together to give us esters, so definitely you are correct that we will have a ester linkage here. Okay, so same logic we have to apply. We will remove OH from carboxylic acids and H from the alcohol side. Now we have to copy down the remaining part. So let's copy it down. We have first the carboxylic acid. Now we have to connect it with the remaining part, which is O box O. Okay, so I'll just draw a bond here, then O, the box O. Then again alternatively I will have to draw carboxylic acid, and again I will draw oxygen, that is alcohol part, and bond extension on both sides. This what you have got, if you remember, is our ester functional group. Okay, so this is having an ester linkage in it. So it is known as polyester. An example of polyester is PET. That is polyethylene terephthalate. Yeah, so in exam you are not supposed to write the full form of PET. You can just write down the example PET if polyester is asked. Earlier we had one more example for polyester which was terylene, but now that is being removed, okay, from your syllabus. So you have to remember PET only, and for your polyamide you are supposed to remember nylon. So same again, here I have removed 2OH and 2H, so we will get 2H2O here. So here water molecule is being formed, and hence we would say this is condensation, polymerization. I hope you have understood both polyamides and polyesters, how to draw the structures. It is very easy. Okay, with your pencil you can just draw a box around OH from carboxylic acid and hydrogen. If it is amines or if it is alcohol, in both the cases hydrogen needs to be removed, and you just have to copy the same structure one after the other alternatively. Okay, connect them with the bonds, and hence you will be getting your polyester. Now next what is remaining is proteins. So let's do with proteins. Now I will draw a general structure of proteins. So we have carbon, we have a alkyl group here, okay, then we have hydrogen, then we have carboxylic acid and amine functional group. This is the general structure of protein. All the amino acids are having this type of structure. The R which we have here can be anything. It can be methyl functional group, ethyl functional group, it can be sulfur, okay, or it can be any other group. We can say any other atom which is attached to carbon that gives rise to different amino acids. Okay, now in exam they give you the structure and ask you to complete the structure of protein. So in that case you should draw the displayed formula of carboxylic acid and displayed formula of NH. You have to show all the bonds and atoms and attach it with the carbon. This comes for I guess 2 to 3 marks. Okay, it comes for 2 to 3 marks in your exam, and many students they get confused and they do not complete the structure and hence lose their marks. But this is very easy. You just have to attach a carboxylic acid and amine functional group to the carbon chain. Okay, so now as we said that nylon and proteins are having the same amide linkage, we would say. So how protein looks like, so we will just draw the polymer of a protein chain. Okay, so here you can consider that I have the same amino acid as my monomer, and I will just attach both of them. So let's draw this. So I have this something like this is my R. Okay, so I will draw it in this format, the box format. Okay, so say for example, I have alkyl chain here. On one end, I am having NH2, on another end, I am having carboxylic acid. Okay, this is what exactly this what we have drawn. Okay, so now here also what I will do, I will remove hydrogen from one end and OH from another end. Okay, this will give rise to water, and this same thing needs to be copied again and again and again. So let's do that. So we are having C double bond O and NH. Again I will be just copying the continuing the same structure again and again. Again I will copy. Yeah, and this is the bond extension. Here if you see, this is the amide linkage. Okay, NHC double bond O. I will just show you the linkage in amide, which is C double bond O NH or NHC double bond O. Okay, so what was the difference in proteins and in nylon, that is synthetic polymer? If you see the difference, the linkage remains the same, but the starting material, that is monomer, for both of them is different. The monomer here in protein is only one type of monomer. You can see that there is the same linkage. The functional groups, carboxylic acid and amine functional group, is attached on the same alkyl chain. On one end we have carboxylic acid, on another end we are having amine functional group. Okay, but if you see for nylon, carboxylic acid is altogether in a different functional group or a functional or a chain, sorry, and in NH2 the amine is altogether in a different monomer. So we require two different monomers for making nylon, the synthetic polymer. Okay, but for proteins we have both this functional group in the same alkyl chain. This is the difference that we have. Rest the structure will look the same because the linkage is same. Okay, so this is all about proteins that we have and about the condensation polymerization, where proteins and nylon are having a similar linkage. Now one more question which is being asked in your exam is, we have to circle one repeat unit of the polymer. So let me draw the polymer first. So I will just draw here. Let me draw the same kind of polymer. Okay, and bond extensions on both sides. Okay, now here in exam they will ask you to draw one repeat unit of this polymer. So in that you are supposed to have one linkage, one your monomer, that is you have two monomers. So one monomer that we have, that is amine here, and another monomer that I have is carboxylic acid. So this is what my one repeat unit of this polymer looks like. So in exam, they will ask you this question. They will give you a polymer and will ask you to circle that. Okay, so you should include both the monomers and the linkage inside it. So this is all about your polymers. Okay, so as we have learned about making the polymer from the monomer, we have another way now, which is we had monomer to polymer. Okay, but here again we can break down the polymer back into the monomer, which is known as hydrolysis. Okay, hydro meaning water. Okay, so in presence of steam, we would say steam, high temperature and pressure, we would convert the polymer back to its monomer. So on hydrolyzing the polymer, whichever polymer we are hydrolyzing, say for example, if we hydrolyze nylon. So nylon was made up of what? Dicarboxylic acid, and it was made up of diamines. So it would give us these two monomers back. Okay, so this is about hydrolysis.